All right, let's go ahead and get started here. I'm assuming that the crowd we have here today is at least somewhat interested in developing real-time dashboard applications without programming. So my name is Tom Lubinski. I am the CEO of a company called SL. And we don't have our little tagline up there, but our tagline is real-time visibility. And basically, for the last couple of decades, I've been involved in various types of applications, from process monitoring control, from IT application monitoring systems, all of which involve access to large volumes of real-time data and ways in which we attempt to visualize that, right? So we're going to talk a little bit today about ways that you can develop dashboard applications, in particular without programming, right? There's lots of tools out there that allow you to build dashboards, but as we'll see, some of the challenges there means that there's work involved, and you want to minimize that for people so you can get as much done as possible. So one of the reasons why I think this is an important topic is that we have a lot of sources of real-time data, whether it's streaming data or whether it's REST data, whatever it is. There's a lot of sources out there, and many applications that are built around these types of data. And the question is, how can you maximize the value that you can obtain from the data? And if you build one application, then yeah, you're going to get some value out of the data. But what we've found is that where there's one application, there are lots of others around the periphery, and that's what we'll talk about here. We're also going to talk a little bit about the challenges that are, we've found over the years are involved in setting up real functional dashboard applications. And lastly, we'll talk a little bit about how we've approached it with our products and in the applications that we've developed. So what I see as the value is that you have a lot of data out there, and you want to be able to share the data with many other users. I was listening to a presentation just before this in the main room there, and Chris Bailey was talking about a hotel application where he's got on his phone his system has the ability to transmit minute-by-minute updates about hotel reservations. And you can be standing in the lobby and get a hotel reservation, right? You find out a new one just popped up and go check in. And you can think of that as the primary application, right? The phone, that's the primary application of that type of real-time data. But if you think about it, think about all the other users out there who are circling around that application. You've got your suppliers, you've got the different hotels who are offering the rooms, you've got the executives, you've got the marketing people who want to promote, what's going on. And that's really the fundamental premise that we have here, is that you've got all these other application services that you want to provide. And in many cases, those services require not just the primary stream of data, which would be the hotel reservations, but also other types of information. Like, what's the weather in certain cities? Are there traffic delays at the airport, right? And so all these things could be factored into applications that offer people services that can generate revenue, which is fundamentally what we're trying to do here. So then let's talk a little bit about what some of the challenges are in achieving this. So people think about real-time streaming data and the promise of all that, right? Every 5 or 10 years, I've seen it in my career, every 5 or 10 years there's some new big emerging promise that's going to solve all the world's problems. And we see some of that in this real-time data era that we're in now. It's going to take care of everything, and you can build things with real-time data now that you couldn't build before. But in reality, it's not quite that easy, right? Because what happens is, real-time data, this is sort of a motto that I have, is that real-time data can be fast, but it isn't always frequent. It doesn't always come in, right? So think about that. You open up your dashboard, and you want to see some temperatures in the cities that you're traveling to. You open up your dashboard, and if the weather information is being updated once every 10 minutes, when you open your dashboard, if you're just tied into that stream of data, what's going to happen is you have to wait 10 minutes before you see the value come in. So it's not just as simple as tapping into the data, right? You have to have the value of the data available. What was the last value that came in, right? That's one of the fundamental problems that people, even when you start out building applications, they tend to forget about, that there's these simple problems that need to be solved. You can't just tap into the stream of data. So this is one of the basic challenges that comes up that we want to talk about how we would address. The other thing that you often need is you want to go back in time and you want to see a history of the data. And if you're just connected to the stream of data, you don't see the history. That history has to be stored somewhere. And from the history, you can observe patterns. What are your traffic levels during the day? What are your customer consumption patterns over week to week and things like that? And you want to see that in conjunction with your current data. So you need to combine history with the current values that you have coming in. You also want to be able to do baseline comparisons. Is this week better than last week? And so maybe you make some real-time adjustments based on some of the factors that you're seeing. And lastly, of course, cause and effect relationships. You want to, you see some history, you see some pattern that emerges, some kind of marketing program results in activity, and you want to adjust according to those things. So history is very important in any kind of a real-time application. Now, this is another one that I think is pretty important. This has to do with scalability. Everybody talks about scalability, but when it comes to servers that are offering up real-time data, you take that example of the weather, right? Now, maybe it comes in every 10 minutes, right? But there are other streams of data that are coming in all the time. And imagine if you have a lot of users. So those little circles there are your different classes of users. So you've got some primary users who are accessing the data. Then you have lots of these other users off to the side that are also consuming the data. Now, if you have 100 other users who just have some casual use of the data, but they want to see what's going on, do you want them connecting to a stream that's giving them data every second, even though they're not really using it that extensively? So what we find is that in order to keep the load realistic on your servers, in many applications you really do have to buffer that data somehow. And you have to be able to have a single point in which a lot of these other users can access the data and not overload your server with all these more casual users. And so I think that's a very important aspect of scalability. And in some cases, these users can be very geographically dispersed. And yes, a company like PubNub offers a great product which can, anywhere in the world, deliver within a quarter of a second your data. But if you have a lot of these users all over the place who want to see it, you have to buffer it in some way in order to really get good scalability. And lastly, the security. One of the things that you have to take into account is that in many cases, especially in banks, we have a lot of banking customers, and they will not let any data out of their own firewalls. So whatever sort of system you develop, it has to be developed in such a way that they can view their secure data behind their firewall. And they may want a service solution. They don't want to install servers, but yet they don't want to ship their data out to the internet. So the question is, how can you build a dashboard system that can be served up through a hosted service, like a SaaS offering, and then allow them to see their data behind their firewall? So these are some of the challenges that we want to talk about. And now let's jump right into the solution. And I'll talk a little bit about how we have addressed this problem. So one of the key things that I find is necessary in a lot of these types of applications, we mentioned buffering before. If you think about that problem of having current values, what happens is that the dashboard, if the streams are coming in on a regular basis, then yeah, you can connect directly to the stream server and you can see the latest values all the time. But if you have streams that are less frequent, or if you want to somehow buffer 100 users so that only one connection to the stream is being made, then you need some kind of a server in the middle there. And that's what we call a cache server. And you see that in many applications. It's not new. It's a very common solution, to this problem, but it has to be an element of building the dashboards. So when people talk about, I'm going to build a dashboard against my real-time data, there's a lot of tools out there and a lot of JavaScript and sample programs that you can set up. But if you don't have this support on the back end for the current values, the history, the buffering in order to get some scalability, then you really can't solve the problem in its entirety. Now, the other thing that we typically do at this cache server level is we also provide persistent storage. So in the cache server that we put together, we have the ability to keep the current value and some in-memory history of the metrics coming in, but you also have the option to persist it out to a database. And in many cases, even though the stream supplier might offer some history, again, PubNub has a history capability, but it tends to be the highly granular data and tends to be shorter term, whereas you may want to put a history of those metrics off into a SQL database where you can then apply some business intelligence software to that. Look at it with Tableau or whatever else you want to use. And so there's often a requirement to store it out in some kind of a SQL database that can be accessed by other tools later. So this is a key part of the solution that we see that has to live behind the scenes in any kind of a dashboard situation. Now, I don't want to talk about product too much, but what we've done is we do have a product that we call RT View, and RT View has a component called RT Draw, which allows us to build up dashboards, but there's also a component that we call RT Data in the back end, which is basically that solution, which is the caching solution. And these things together offer that sort of complete dashboard solution. And with that being said, I'm just going to now take a look at some of the ways that we address those challenges. And of course, one of the challenges is you need to distribute the dashboards across different types of devices. So you not only want to see it on your desktop, you want to see it on a mobile device and also a tablet. So obviously the solution has to be somewhat responsive and have all those capabilities. So that's another challenge in building dashboards. A lot of the simpler tools that you see available, you don't always have everything you need to make it completely responsive. And those of you who have worked with Bootstrap or any of these other tools, it's not always as easy as it's made out to be, right? So the other key part of a solution like this is that if you're going to be attempting to offer something that is building dashboards without programming, you want to make it accessible to a lot of people. And if you don't want to invest a lot of money in the programming aspect of it, you want to have it as a hosted service. So a hosted solution would be optimal in this situation, so that you don't have to install servers. I mean, think about if you were to build a dashboard solution with some existing product tools, JavaScript libraries, you would then be responsible for hosting that server in your own environment somewhere. So obviously a SaaS solution is going to be easier to deploy. So when we talk about building dashboards without any programming, what we're really referring to here is obviously having a palette of objects that you can choose from, and then being able to just drag those into a canvas of sorts and basically create a web page out of that. And the key here is that without any programming, being able to attach those objects to a stream of data or a cache of data or a REST API somewhere out on the internet in order to assemble a view of what is going on in your organization. And so if we take a look here, so the idea would be that you would right-click on that object and bring up a dialog where you could then attach to the stream, set up your data connection properties and so on, and attach to the stream. But a key aspect of this is that if you build these dashboards and you have them on your desktop where you've built them, how do you make them available to the rest of the people in the organization? And this, over the 20 years or so that I've been doing this is one of the problems that I found most often people encounter, is that you could build some very good stuff, but if it sits on your desktop and it doesn't get shared with other people, it never gets used, right? And unless you're the hosting for it, people don't use it. So a key part of the solution, as I see it, is that in that hosted offering, by maintaining a database on the server, on the hosted server, of any dashboards anybody creates, organizing those into groups within an organization, being able to share those with your group, share those with individual users. Think about it like Salesforce. That's the problem that Salesforce solved when they said, let's take all of your sales information and make it available to groups within the organization. And it's the same sort of thing here. We're building a system that allows you to organize all of your visualization and real-time assets in such a way that you can share them with other people. And of course, many different styles of visualizations. We have a lot of heat maps and trend charts that you might apply to these things. This here is an example of some trend charts and some current values that we've attached directly to some PubNub sensor data. They have the public demo stream, and we've just connected right up to that. But the key here is that history, that sensor stream doesn't provide history, right? So we have that stored in our back-end cache server so that we can put this kind of display together. Oh yeah, we have a table if you're interested in seeing an example of what we have here. So here's another example of. So this is a telemetry application, right? There are other tools that are available that are more BI oriented that can do trend charts and bar charts and things like that. But we in particular have a lot of experience from previous years in dealing with process control type applications. And this is some space station data, live data coming from the International Space Station. And we also are accessing REST APIs. This is a map that we have showing the current location of all the BART stations and so on. And so it's a short presentation, but I just wanted to give you a taste of what we do here. And the thought I would leave you with is when you think about building dashboard apps, it's not just tapping into the stream. There's quite a bit more to it than that. So I don't know if I went over the time. If we have some time for some questions, if anybody's interested, you can talk to us. Yes?
So you mentioned some of the complexities involved with binding data to things like Bootstrap, et cetera.
Mm-hmm.
And I kind of just think that it's kind of a short way to think about it,
mm-hmm.
considering that we have all these new, more spatial tools in which we can understand things.
Mm-hmm.
Have you had any experience kind of wrapping the data from your dashboard into three-dimensional space? Your last slide showed that you guys are doing some stuff with the BART data
mm-hmm.
and the Maps API.
Right.
Have you guys been able to rotate that, give some access?
Well, the answer to that is yes and no. I mean, I've been doing this for a long time, and we have certainly explored various three-dimensional approaches to visualizing data. There's lots of tools for visualizing data in 3 dimensions, and believe me, it's of great interest. But as a commercial company, one of the things we found is that the larger audience tends to need some simpler things. So while you're absolutely correct that you could do some beautiful 3D visualizations, right now we're in the stages where we're trying to get the maximum functionality for the most people with the least effort, right? And you start looking at 3D, the whole conceptual model, it's a bigger reach for people. And so it's just a business question, right? It's not that we couldn't do it. It's just, do we want to offer that right now? Does that make commercial sense?
Yeah, what kind of standard are you using to connect to streams?
Well, it'd be nice if there were a standard. I mean, right now the REST API is a standard. That's not stream data. That's often real-time data, and it's a poll. But the streams, typically, the different vendors have their own protocol. You connect to PubNub, you use their API. You connect to Stream, you get theirs. Lightstreamer, you use theirs. So it's different for every supplier.
How do you compare some? Where you find, where is your strength comparing to other providers like Tableau, Jasper, Workspace?
Well, yeah. So how do we compare to other products was the question. So there are lots of products out there, right? There's especially BI. You look at something like Tableau, it's a great product, right? And a lot of those products tend to be oriented toward database queries, and they're built with that architecture in mind. So when you build a solution like this that is aimed at real time, you start entering into a whole new space, and the requirements of their solution are very different. The updating in the background of the data, how do you really optimize that? That's something we have a lot of experience with, and it's very easy to make it update, but it's not so easy to make it update if you have 100 objects updating. Right? And they're all connected to different sources. How do you optimize those types of things? So it comes down to who does it better, right? I mean, there are, even here we have Microsoft BI, it's similar to what we're doing here, but it has more BI roots that are from static data. And, I mean, we have specialized for years in real-time. Our solution allows you to build diagrams and move objects around and to organize objects into nested groups that you can repeat hierarchically. These are all features that some applications require and some don't. And once you start getting into IoT and telemetry and all this sort of stuff, you need some of that more advanced functionality. And so the simpler products just, even though they're similar, they just don't do it. Mm-hmm.
Talked a little bit early on about cause and effect, so I'm wondering what your solution offers as far as finding correlations in real time with real-time streaming data.
So we've been, our company has been doing this kind of stuff for a long time, and previous generations of the product that were built on Java and even before that on C++, there were more analytics type functionality built into it. Okay, this particular generation that I've introduced here is a browser-based HTML5 JavaScript solution, and is still in the early stages of evolution compared to some of the older, the earlier products. So at this time, the analytics are pretty limited, right? In the previous generation, we had a whole mechanism developed for identifying what we referred to as key metrics that you could then compare one another and see historical trends and see correlations in those key metrics. And over time, this same kind of thing will emerge. And some of that is actually done in the back-end server and is already somewhat available, but surfacing all of that in the newer generation of interface is yet to come. Right? Mm-hmm.
So I see that this is a very contextual sort of way to look at data visualizations, and you introduced something called like the cache layer, like a cache layer. How much wiggle room or how much space to play do I have in that cache layer? So say I have something that is sitting in the cache, but I want to make some changes based on the context of the user's current actions to what I already have in cache. Do I have the ability to interact that way?
So the question is, how much control does he have over the caching layer, right? And actually, the caching layer there is actually a carry forward from existing functionality that we have, and that is a Java-based server component which has a lot of functionality and a lot of openness and flexibility. So there are several ways that you can interact with that caching solution. One is, send it data and just, automatically build a cache of your data. Very simple. But you can also put all sorts of, analytics functions. You could put all sorts of, correlations or triggers, even interactively, change the content of that cache. So there's a lot of ways you can control what is in that back-end cache, if you want to. That starts to get into more advanced usage of the products, right? But it is quite doable.
But just to follow up on that point, so that would be something you'd have to do from an administrator IT perspective. It's not something like an end user can say, "Oh, alert me if this value goes to the."
Well, that's. Yeah, so the question was, is that an admin function or is that an end user function? And most of it, I would say, yes, would be more of an admin function. An IT person configuring the behavior, the special behavior of that cache on the back end. But at the same time, there are certain things that an end user is capable of doing, such as defining alerts. Right? Those are some common functions, or sending data to it and just having it automatically create a cache and configure it to go to the back end MySQL database. So certain things the end user can do, others are more admin oriented. One more question.
Do you have some tools which are kind of compared to ETL functions when you ingest data from database, like something where you can filter, transform data from stream that's coming through?
That's right. In that cache layer, and actually in the dashboards themselves, you have the ability to put functions. We have a standard set of functions, to do joins and things like that. And you can also put your own custom functions. So that goes to the flexibility question. There's a lot of flexibility in this system, partly because it's based on things we've learned over many years. So they're telling me that our time is up. Anybody who wants to hang out and talk for a little longer, I'm here.